Hello my dear friends, welcome back to the second part of the 6-mark questions from the question bank provided by the Nagaland Board of School Education. So I'm sure that your preparation is going on very well, and I'm definitely very sure that this video of course again will supplement your preparation also. So now just straight, let's get to the point, moving on to the second part. So in that first part, the first video, the part 1 video, if I remember, I have solved up to the application of derivative part. That's up to question number 4. So now we'll move on to question number 5. This is from application of integrals, area of bounded regions. So here, as mentioned, this year the syllabus, the reduced syllabus, area between two curves has been reduced. So that's like basically 8.2. But the other exercises can be important, will be important. Okay, now this question. Find the area of the region in the first quadrant. Find the area of the region in the first quadrant enclosed by the x-axis, the line x equal to root 3y, and the circle x square plus y square equal to 4. Let's get it done. Solution. Let's first the circle. The circle is, I'll write straight, 2 square. So that means here the radius is 2 units. So our circle, its radius of course will be now 2 units, because from the equation of circle, x square plus y square equal to r square with center at the origin. So I guess those basics are known to you. So basically if we just diagram, of course will hold the key to area bounded regions. Okay, so basically if we draw the figure like this is the origin. So the radius of the circle is like 2. So that means from the origin, this is at a length of 2 units. So maybe we can just name this as A. Then, and then of course, it is going to be perfectly symmetric because the circle is about centered at the origin. So please excuse my circle, it looks terrible, but it's okay, that doesn't matter, isn't it? Okay, now, of course it says only the first quadrant, so at least in the first quadrant it looks like a circle slightly, so please excuse me for my figure. And enclosed by the x-axis, fine, no problem, and the line x equal to root 3y. The line given is x equal to root 3y. So now x equal to root 3y, so if you just do it roughly, just quickly, it's like if y equal to 0, then definitely what happens? X is also equal to 0. That means this is a straight line that is going to pass through the origin, something like this. So this is, let's say, our line N. So now what we're supposed to do is we're supposed to find out the area enclosed in the first quadrant by the line and the circle, this area. So you will see that the line will intersect at a certain point on the circle. So what we will do is we will drop a perpendicular from the point of intersection to the x-axis. Let's say, let's name this as B. This as, let's name this as C. So now first our job is to find out the point of intersection where the circle and the line intersects with each other. So for that, let's solve. So let this be equation 1. Let this be equation 2. So now let's solving. So from straight get to the point from 1. Instead of x, I'll use equation 2. So that's going to be root 3y whole square plus y square equal to 4. So that's going to be 3y square plus y square is equal to 4. So that means y square equal to 4y square, that's 1. I guess you can get that point there. So y equal to 1 plus or minus 1. Simple mathematics. Y equal to plus or minus 1. Fine. I'm going to rub the question now. Okay. I need more space. So in that case, as we can see, when y is plus 1, then the value of x will be root 3. And when y equal to minus 1, x will be minus root 3. That means the point of intersection of the line and the circle, C will be root 3, 1, and this point, which of course we don't need, minus root 3 minus 1, third quadrant exactly so. So now here we see that the point of intersection is solved. So when we drop a perpendicular, this point B will be what? Root 3, 0, because we are dropping it from the point of intersection of the circle and the straight line, root 3, 1. So we drop a perpendicular, this will be root 3, 0. Okay? Alright. So now it's quite simple. Let's find the area bounded. It's very simple. This is done. I'm rubbing it off now. Okay? Chalo. Alright, so our limits are already derived. So of course we can just write down the line and the circle intersects at one point is root 3, 1, and the other point, which for our context is not needed, minus root 3 minus 1. Anyway, but it's good to write because for other questions that's how you will be doing. So now what we do is we drop CB, that's going to be perpendicular to, let's say, OX, such that our point B becomes root 3, 0. Different ways of solving, different ways of writing. As I always say, mathematics, different people, different teachers have different ways of solving. Just as mathematically and conceptually it has to be correct, that's all. Okay. Alright, that's it. Let's find out the area of the bounded region then. Like, let's say required area. I'm going to do it in detail. That is going to be like area of the region O A. Now this point is A, O A C O. OACO, bounded region. So I'm coming back again. Now OACO. If you want, we can write an arc also like this. OADCO, and all not needed. That is understood. So that will be what? We'll break apart this into two parts. This is one area, this one. And the second part will be this area. Alright, so that is going to be area of OBCO plus combining the area of the other region, that is BACB. I think that's fine. BACB, bounded regions. Alright, fine. Now this area OBCO, this area, this triangle is bounded by the straight line, isn't it? Up to here, now bounded by the straight line. So this will be bounded by the straight line with respect to x, since we are doing it with respect to the x-axis. Interval, limit, it goes from 0 to, that's why I dropped the perpendicular now, 0 to root 3. 0 to root 3 plus the remaining area that is actually bounded by the circle, this area. That is like y, I'll just write down bounded by the circle with respect to x. Now here the limit, it starts from here now. Now first one was 0 to b, next will be b to a. That is root 3 to 2. Root 3 to 2. So now our job is to integrate this by taking out the functions. I am rubbing this part. So that will be 0 to root 3. What was the equation of the straight line? The equation of the straight line was, I'll just write here, x equal to root 3y. So that means y will be x by root 3. So that is x by root 3 with respect to x plus root 3 to 2. What was the equation of the circle? X squared plus y squared equal to 4. So y squared equal to 4 minus x squared. So y will be root over of 4 minus x squared. I think that's fine. That's going to be 4 minus x squared with respect to x. These are our equations. Alright. So now our job is to now integrate. Get back to integration and then integrate. So 1 by root 3 out, since it's a constant, x with respect to x, 0 to root 3, plus this one, okay, I'll just rearrange, 2, 4, I can write it as 2 square minus x square with respect to x. So that's going to be 1 by root 3, integration of x is x square by 2, 0 to root 3 plus this integration, special integrals, a square minus x square. A square minus x square, special integrals, a square minus x square. What was that? X by 2 root over of a square minus x square, wasn't it? You check the formula there, root over of a square minus x square plus a square by 2, because our value of a is 2, isn't it? So a square by 2 sine inverse x by 2, sine inverse x by 2. I guess this is done. Within our interval root 3 to 2. Upper wala done. I'm rubbing it off, okay? Very simple question, of course. So now we can substitute the limits, 1 by root 3, upper limit. So that's root 3 square by 2 minus, of course, 0. Plus here, let's start with the upper limit, 2. So that's like 2 by 2 root over of 2 square minus 2 square instead of x. Now this is 4 by 2 sine inverse 2 by 2 minus root 3 by 2 root over of 2 square minus, I need more space, this is done now. So I'll just write here. So that's going to be root 3 by 2 root over of 2 square minus root 3 whole square plus 4 by 2 sine inverse root 3 by 2. Integration, definite integral, I guess that's familiar to all of you. 1 by root 3, this is going to be 3 by 2 minus, plus, this is 2, this is of course 0 plus 2 sine inverse 1, fine, minus root 3 by 2, this is going to be 4 minus 3, that's 1, plus 2 sine inverse root 3 by 2. I guess this is fine, don't confuse with this line, okay? Of course, if you are following the video, definitely there is no point of confusion. So this, of course, 3 root 3, that can be simplified, plus 12, I guess you can do this, root 3 by 2 plus 2 sine inverse 1, that's pi by 2, plus, that's again, minus root 3 by 2 plus 2 sine inverse root 3 by 2, so that's sine 60, that's pi by 3, so that's pi by 3, isn't it? 360, yes, pi by 3. So root 3 by 2, pi. So we are left with pi minus 2 pi by 3. So taking the LCM and simplifying, we will have pi by 3 square units. Pi by 3 square units. Okay? Alright, a simple question only. Done? You can pause the video here. Alright. Next question. Okay, the second option, the next question is from area of two curves. So we're going to be skipping that as per the syllabus. So number 6A. Find the area of the region bounded by the curve y square equal to 4x. This is a parabola with vertex at the origin. You have to recognize the curves, okay? And the line y equal to 3. This is a very easy question. So in case if you get this question in the exams, at least stand up once, shout with joy. Like, I got that question, because this is a very simple question. Okay, so you should be very, very happy if you get this question. Because, I'll show you. y square equal to 4x is a right hand parabola. Of course, no need to write too much in details with vertex at the origin because that's a standard form. So let's say this is the parabola. Y square equal to 4x, because the right hand parabola is like y square equal to 4ax, where a is the focus and so on. And the line y equal to 3. So the line y equal to 3 x y. And the line, not y equal to 3, and the line x equal to 3. And the line x equal to 3. Of course, that doesn't change anything. Question remains simple. Once again, find the area of the region bounded by the curve y square equal to 4x. Fine. And the line x equal to 3. That makes it more simple again. And the line x equal to 3. So maybe somewhere we do not know. So let's just assume that this is x equal to 3. So this is the point. We can write 3, 0. Maybe we can name M. A. Well, line x equal to 3. बस हो गया काम खत्म. So find the area of the region bounded by the curve y square equal to 4x. Okay, the curve curve y square equal to 4x is what? Symmetric. S-Y-M-M-E-T-R-I-C. Symmetric about x-axis as it has even powers of y. I guess you know that, isn't it? When the power of y is even, the graph will be perfectly symmetric about the x-axis. When the graph is, when the curve equation has even power for x, it will be perfectly symmetric about y-axis. Like for example, if it is x square equal to 4y, then the graph will be x square. So this graph, whatever curve, it will be perfectly symmetric about the x square, 4, 6 even powers. That is going to be perfectly symmetric about the y-axis. Y-axis will be cutting the graph into exactly 2 parts. That's why circles equation is generally like x square plus y square. Just now we did, no? Is equal to 2 square. That was like x square, x-axis, x square. So about the y-axis also symmetric. Y square, that means about the x-axis also symmetric. So that's why like all 4 quadrants same. That's how basically it works. I guess, of course, this one I am sure you already know it. I'm just reminding it once again. So now that's simple. So let's say, so since this is perfectly symmetric, our area is going to be like this. This whole area. So required area will be like 2 times of area of OA, let's say B, okay? OABO. Why 2 times of area of OABO? Because as I said, it's perfectly symmetric. So that means these are of same halves, same area, same part. So instead of finding out for the whole, we just find out for this region and double it. It will give you the total area. No? Half. Because it's perfectly symmetric, half. Alright, very simple question. So, done. So that is going to be 2 times of integral of y bounded by the parabola with respect to x. Limit is from, of course, 0. It goes on till 3. Limit goes from 0 to 3. Y square equal to 4x. So that's going to be 2 times of y square equal to 4x. Na? Y square equal to 4x. So y will be root over of 4x with respect to x. Limit is from 0 to 3. So that's like 2 times of 0 to 3, 2 root of x with respect to x. So 2 2s are 4. Integration of x is, root x is 1 by 2 plus 1. So that's like 3 by 2. Integration, so I'm not doing that in detail. So that's like 4 into 2 by 3. 3 3 by 2 minus 0. Upper limit minus lower limit. So that's like 8 by 3. This is like 3, 1 by 2 whole cube minus 0. Minus 0, why am I writing? It's already done. So that's like 8 by 3 root over of 3 whole cube. So that's like 8 by 3 cube root 3 whole cube. So that's like root 3, root 3, root 3. So root 3, root 3, that's like 3, root 3. So that's 8 root of 3 square units. Since it's area, it has to end with square units. Okay? Alright. Done. You can pause the video there. I'm rubbing it off. Alright, let's move on to the next question. This is going to be from three-dimensional geometry. Question number 7a. So that's like find the shortest distance. Find the shortest distance between the lines. Find the shortest distance between the lines. Vector r equal to I plus 2j plus k plus lambda I minus j plus k, and the other line is 2i minus j minus k plus mu times 2i minus plus j plus 2k. Alright, so what was the formula for the shortest distance? Solution. What was the formula for the shortest distance? Shortest distance between two lines is given by magnitude of m1 cross m2. m1 and m2 are the parallel vectors. In some textbooks, instead of m1 and m2, they write b1 and b2 because basically they compare it with r equal to a1 vector plus lambda b1 vector. For us, we are comparing it with r1 vector plus lambda m1 vector. So vectors don't mean anything, okay? I mean, it doesn't mean anything. I mean, as long as our concept is same. And this is r2 vector minus r1 vector, magnitude of the cross product of m1 cross m2, whole magnitude. So this is the formula for the shortest distance between two lines. So we have to find out some values. So let's find out the values one after the other. So, okay, let me start with m1 cross m2. So m1 cross m2, okay. Let me just write down here. So what is r1 vector, r2 vector, m1 vector, m2 vector. So r1 and r2 are the position vectors. So I plus 2j plus k, r2 2i minus j minus k. m1 and m2 are the parallel vectors. I, j, k. This one 2i plus j plus 2k. Alright, this is r2 m2. This is r1 m1. Got that? So let's find out m1 cross m2. So it's cross product I, j, k. So I, j, k, 1 minus 1, 1, 2, 1, 2. So done. I'm rubbing this part. So it's cross product as I have done before. Let's prepare j, k. So let's go for the cross product. Minus 2, minus 1, right? Minus 2, minus 1. Next is 2, minus 2. Next is 1, minus, minus, plus 2. So I'll just write here. So that's going to be minus 3i, this is 0, plus 3k, plus 3k. So that's m1 cross m2. So its magnitude, which we will also need again, m1 cross m2, that's like root over of 3 square plus 3 square, so that's like 9 plus 9, so that's like root over of 18. Square root of 18, 3, 6, 3, 3, so of course that's going to be 3 root over of 2. Next, R2 vector minus R1 vector. So that's like I plus 2j plus k minus 2i plus j plus k, minus minus plus, na? So that's like minus I plus 3j plus 2k, minus I plus 3j plus, R2 minus R1, so R2 minus R1, 2i minus j minus k, minus I minus 2j minus k. So that's going to be 2i minus I minus 3j minus 2k. Alright, so therefore shortest distance, I'm not writing down the formula again. So m1 cross m2 was minus 3i plus 3k dot product into I minus 3j minus 2k into its magnitude was 3 root over of 2. Alright, it's about just knowing your formulas, and then the rest of course is just simple about your arithmetic or the multiplication, addition and all. You just have to be careful, not like me, don't be careless there. So that's like minus 3, so dot product minus 3 into minus 1. J is going to be 0 plus k 3 minus 2 divided by 3 root over of 2. Magnitude, shortest distance, so distance is always going to be positive, no? So that's like 3 minus 6 divided by 3 root over of 2. So that's like minus 3 divided by 3 root over of 2. So that's like positive 1 by root 2 units. 1 by, just check once. Slight mistake there. Minus 3 plus 1. I don't know from where I got this. Minus 3, as I was telling you not to be careless, it went there. Minus 3 plus 1, so that's going to be minus 3. So that's minus 9. So that's 9 by 3 root over of 2, so that's like 3 root 2. 3 divided by root 2 square units, so that's going to be 3 root 2 divided by 2 units. So this is the shortest distance between the two lines. Lots of careless mistakes there. Actually, that's as I always say, no? Done, no? Rubbing it off. Okay. As I've mentioned, when we do on the board, no, it's somehow quite difficult for us to, because we don't see it. Now, what is rubbed. So that's what happens. I'm just making an excuse. Number 7b. Find the vector equation. Find the vector equation of the plane passing through the intersection of the planes r vector dot 2i plus 2j minus 3k is equal to 7, r dot 2i plus 5j plus 3k equal to 9, and through the points, and through the point 2, 1, 3. and through the point 2, 1, 3. So as we know, solution, what was the equation? Like equation, okay, I'll just write down equation of plane through the intersection of two planes R dot A minus D and R dot B minus D2 equal to 0 and D2 equal to 0 is R dot A minus D1 plus lambda R dot B minus D2 is equal to 0. This was the equation. Of course, don't mind the letters as I've mentioned before. I know the textbook, I don't recall. The letters, of course, as I say, can be different. Now, letters, so don't be so worried about that. But I'll just check and confirm. Plane passing through the intersection of two given planes. Okay, they have given it in a different way, so I'll just give you that one so that you don't confuse. We follow different textbooks, so that's why. It's same actually, almost same. So I'll give you what the textbook has given. I follow other textbooks, so that's why. But so that you don't confuse, it's same only. That is, R vector dot n1 vector equal to d1 and R dot n2 vector, normal vectors, d2 is given by vector R n1 plus lambda n2 is equal to d1 plus lambda d2. So that's what the textbook gives you. So I'll also give you that only, so that especially during the exam time I don't want to be confusing you at all. So then what does our equation become? Then our equation becomes vector R. What was our n1 vector? The normal vector, this one. 2i plus 2j minus 3k, right, plus lambda into n2. n2 vector is this one. 2i plus 5j plus 3k is equal to d1, what, perpendicular distance, 7 plus lambda into d2. Lambda into d2, that's 9. Let's mark this as equation 1. Not equation 1. Let's leave that later on. Okay, so I'm rubbing this part. Okay, pause and rub. I need the points. So let's simplify this a little bit. So that's like vector R, line vectors 2 plus 2 lambda I plus 2 plus 5 lambda j plus, don't write this minus, okay, just write plus. You write the coefficient inside only. Minus 3 plus 3 lambda k is equal to 213, 213, 213, 213. I'll write here 213. I don't want to be forgetting the point. 7 plus lambda into 9 or 9 lambda, whatever be it. So, alright, let this be our equation 1. Or we can solve it further. We'll solve it further again. So now substituting the value of R. What was the value of R? regular vector x, y, z. And this one 2 plus 2 lambda I, 2 plus 5 lambda j, minus 3 plus 3 lambda k is equal to 7 plus 9 lambda. Let us use this as equation 1. Okay, this one let's keep it as equation 1 because we want the vector equation, isn't it? We want the vector equation of the plane. So our priority here is now to find out the value of lambda, because lambda is what is giving us the problem. Because this is our equation, it's already there with us. This is our equation, but it's not complete. Why? Because the value of lambda is missing for us. So we need the value of lambda here. So all this are now done to get the value of lambda, because once we get the value of lambda, again we are going back and replacing the value of lambda by our found out values, value of lambda, which will give us the vector equation of the plane. This is the equation, almost complete, slightly incomplete because of the value of lambda. So now we're going to find out the value of lambda, and for that another condition is given to you there in the question. So that's why we are solving this a little bit. Okay, so now dot product, this is dot product. Okay, dot, so now dot product I, j, k, k, dot product, I guess you know. So what was this? Not I, 2, no? Yeah. 2 plus 2 lambda x plus 2 plus 5 lambda y plus minus 3 plus 3 lambda z is equal to 7 plus 9 lambda. This we can mark maybe as equation 2, not a big problem. Now the second part of the condition says it passes through the point 2, 1 and 3, our required plane. So the required plane passes through the point 2, 1, 3. Passes through the point 2, 1, 3. So I'm going to rub this part now. I'll leave this, no need to write, okay? But I'm leaving this because I need that equation to get my final equation, the vector notation. So since the required plane passes through the point 2, 1 and 3, so definitely the values of x equal to 2, y equal to 1, z equal to 3 will satisfy equation number 2. So equation 2, I'll just write implies directly. 2 plus 2 lambda into 2, x, y, z, 2, 1, 3. 2 plus 5 lambda into 1 plus minus 3 plus 3 lambda into 3 equal to 7 plus 9 lambda. Let's solve this. So 4 plus 4 lambda plus 2 plus 5 lambda minus 9 plus 9 lambda equal to 7 plus 9 lambda. 9 lambda, 9 lambda cancels. Then what are we left with? Here we are left with 9 lambda again. Here 4 plus 2, 6 minus 3. Minus 3 equal to 7. So 9 lambda equal to 10. Lambda equal to 10 by 9. So we have our value of lambda, which was missing for us. Alright, so now we have the value of lambda. So now we'll go back to equation. Therefore, the required equation of plane, the required equation of plane from 1, this is our equation. So the required equation of the plane, that's from equation 1, will be, instead of just lambda now, we are going to be substituting what? 10 by 9. Here also 9 into 10 by 9. So 9 here cancels. Taking the LCM within, vector r equal to 9 into 2i plus 2j minus 3k plus 10 into 2i plus 5j plus 3k all divided by 9 is equal to 7 plus 10. vector r 9 to the 18I plus 18j minus 27k plus 20I plus 50j plus 30k equal to 17 into 9. So that's like vector r into 18 plus 20, that is 38I plus 50, 68j plus 3k is equal to 7 9s are 63, 6 left, 153. So this is our required equation of the plane passing through the intersection of two planes. So it's not a very difficult question. You just have to find out the value of lambda but simply by using the concept of dot product and dot product only, nothing much. Okay, all right. So now it has to fall every time. So now number 8, that's question number 8. Same question, Xerox copy, just that the numbers are changed. Number 8 also says find the shortest distance 8a. Find the shortest distance between the lines whose vector equations are this and this, exactly like number 7a. And 8b, same, find the vector equation of the plane passing through the intersection of this vector, this plane and that plane, and passes through the point 1 1 1. So it's exactly the same of question number 7 only, just that the vectors are different, the coefficients are going to be different, the numbers are definitely going to be different. So I guess that you can also manage. It's exactly the same. That will be good practice for you also. So it's going to be exactly the same, just as I say, the vectors are different, but nothing else is different. It's everything is same. All right, so I'll leave you there for today. So kindly do these questions, definitely I am sure will be helpful. And from area of bounded regions, do try some other questions also, because there are other questions also from the first exercise also which are quite important also. So you can do some questions for the miscellaneous also, that will also be helpful. I mean chapter 8, that is also going to be helpful for you. All right, okay then, so I hope that I have been helpful to you at least up to some extent. If I was helpful, please do share this video with your friends. Don't forget to like, give me a like please. And yeah, do subscribe if you haven't subscribed yet. All right, so hope to see you more again. All the best. I'll see you very soon again. Okay, take care all of you. Please stay safe. Wear your masks also. Bye bye.